Good morning, everyone. I hope you had a good fall break. Again, back to your questions. How did the homework go? Please put your questions on chat so we can work on them. Okay. All right, I guess that's about, okay, I'm putting them down. All right, so before I take all your questions, because I know we're gonna work a lot on this section today, I need to ask you a few questions so the whole section will actually make sense to you. And then I will go back and work on all your problems. So questions that are really to deal with the chain rule. So let us say, I give you the following. I give you f of x to be the sine of little f of x. So you don't know what f of x is, but I give you f of x to be the sine of it. And my question to you is find f prime. And your answer should be expressed in terms of f and f prime, little f and little f prime, okay? So I have f, which is sine of f of x, but I'm not giving you f of x. Like imagine sine of x squared or sine of square root of x. But so my question is find the derivative of f and express it in terms of f and f prime. Okay, you guys have a minute to do that, and then I see what you guys got. Okay, if anybody ready, please unmute yourself. Anybody beside Elizabeth? Yeah, I saw your answer, Elizabeth. Okay. So what's the idea here? My inside is f of x. So the way we split this is that my inside is, that's what I call it u. This is the f of x. And my outside will become, let me call it sine of u. That's the outside. So derivative is going to be the derivative of the outside, which is the cosine, evaluated at the inside, times the derivative of the inside. Okay, so I'm going to give you a few problems along those lines, and then I go back to your questions. So hopefully everything will make more sense. Suppose I give you f of x equal x squared times, for example, f of x to the power 3. My question is find f prime and express your answer in terms of f. Again, you have a minute to do that. And please, I want somebody.
I have a question.
Yes, please go ahead.
How'd you get the first one? I'm a little confused.
This one?
Yes.
Yes. If I don't give you f of x, okay, suppose I give you a very specific function. Okay, so let us say I give you the following. F is the sine of x squared. All right, I don't give you a specific function. How would you find the derivative of it? We split this, we have to look at this as a chain rule. The inside is x squared, so the inside is u equal x squared, and the outside is going to be the sine of u. Are you with me?
Yes.
So what's the derivative of the outside now? That's the sine. The derivative of the outside is The cosine.
Wouldn't that just be cosine?
Yes. Evaluate it where? The chain rule tells me.
Do the x squared?
Right. You times it by what? The chain rule is a product. Derivative of the outside, you evaluate at the inside. You multiply it by the derivative of the inside.
Oh, okay.
It means it's cosine x squared times 2x. Got that?
Yes. Thank you.
Now, is my problem similar? Is my problem similar to that?
Yes, I think. Yeah,
Since it is similar.
Because it's
go ahead.
Because I'm thinking it's both sine, like they both have sine with a factor inside. The only difference is that you really can't fully make f of x to a derivative. Like
So what did I do? What did I do?
You just put f prime of x.
Exactly. Is this better?
Yes, thank you very much.
No problem. Now, all of you get going. Number 2. Okay, who's ready? Elizabeth, hold on to the answer. Who's ready?
I think I am.
Go on.
All right, I got 2x times 3 times f of x squared, and that multiplied by f prime of x.
Who would like to correct your classmate's mistake? Okay. It's not bad though. It's not bad. But then what's the mistake? So the answer your classmate gave me 2x times 3 f of x to the power 2 times f prime. What is the mistake? No, look. No. What's the mistake? I want somebody to really look at it and find the mistake in it.
It should be 2x times f of x to the third. You don't take the derivative of that. Do you take the derivative times the f of x?
No, you're not nailing it down. There is one word that will save us.
So you have to add the exponents from x squared to the f of x cubed?
No, you're not nailing it down. Let me give you a problem. And then I want you to see what the mistake is. Suppose I give you the following. Forget about that for a split of a second. No, actually, I don't want to forget about it. Suppose I give you the following. X squared sine x to the power 3. Very typical problem I usually give. How would you find the derivative of that? What do you see first? What do you see first? Okay, Elizabeth gave you the answer, but I want all of you. Don't look what she said. What did you see first? Well, how would you do that? I'm listening.
I don't remember if I don't think it's called the chain rule, but
You
do
product rule?
Right.
Yeah.
That's a product rule. There is no chain at the beginning. The chain is coming later on.
Yeah. I didn't remember what it was called.
You better do because your exam is on Thursday, on whatever, Friday. If you guys engineering major, you're gonna use this almost every day of your learning period. That's product rule. So before you even use the chain rule, you're starting with a product rule. Are you with me? Do you guys know his mistake now? So what the product rule will tell me is the derivative of x squared times, so now we're not really solving our problem, but we're solving very similar, plus x squared times the derivative of sine x. Right now is where I'm going to use the chain rule for that. So times the derivative of sine x to the power 3. Okay, so now this will give me 2x sine cube x plus x squared times. At this stage, I use the chain rule. So now I'm using the chain rule. So what's the derivative of sine x to the power 3? Is the power times sine x squared times the derivative, which is cosine. Okay? So can we now fix the mistake that your classmate did in the previous one? So this is just to tell you what's really going on. Now I go back to this one. What's the derivative? What should be the, so what your classmate did, instead of using the product rule, he said it's the derivative of x squared, which is 2x, and he times it with the derivative of f of x to the power 3, which is 3 f of x squared f prime. So this is the derivative of f of x to the power 3, and this is the derivative of x squared, but that's not the answer because we have to use the product rule. So now we use the product rule again. So that's one function times another function. So the derivative is going to be the derivative of x squared is 2x times f of x to the power 3, product rule. So this first is a product rule, plus x squared times f of x to the power 3, the derivative of that. Okay, so now it's equal to, this is 2x times f of x, whatever f of x is, sine, I don't care, but I just didn't give it to you, which is okay, which is what I will do on your exam, plus x squared times. Now here, I need to use the chain rule for this function. That's what I am using, the chain rule. And now the chain rule tells me what? My inside is f. My outside is u to the power 3. So the derivative of the outside is 3 u squared, but instead of u, I put the inside, times the derivative of my inside. And finally, I mean, there isn't much simplification we can do here. Plus 3 x squared f of x to the power 2 times f prime of x. Okay? All right, I will give you one more and then I will start going back to your issue, okay, to the implicit differentiation. So 3, again, along the same line, I'm not changing the scenario. So suppose I'm just changing, you guys done writing? Can I move a paper? Okay, so if you don't answer, I move. So now my example number 3 is the following. Suppose I take f of x equal, x for example, e to the power f of x. Again, my question is the same, find f prime. Your answer should be in terms of f and f prime. Right? Who feels comfortable to tell me the answer? Who's ready? And don't be afraid of doing mistakes. Only with mistakes you learn.
Would it be e to the f of the x plus x multiplied by e to the f of the x?
You missed something crucial. So that's the product rule, right? So the derivative of x is 1 times e to the f of x plus x times the derivative of that. Okay? Now, what's the derivative of e to the f of x? Now I take you back to a scenario. So let us say instead of e to the f of x, I had, so let me put this scenario. Suppose I have e to the sine x. What's the derivative of that? So I'm assuming f is sine. What's the derivative of e to the sine? Is this a chain rule problem? Yes or not? Okay, it's a chain rule problem. Kiana, what's your inside? Sorry, what's the outside? Kiana? You can just write it on chat if you want. What's the outside? Okay, e to the x or e to the u if you want. And the inside is the sine. So it's going to be the derivative. It's derivative of the outside, which is e to the u, but instead of a u, I put the sine, times, that's a chain rule, the derivative of the sine. Okay. So what's going to be the derivative here? It's the same thing, e times. At this stage, this is f of x, that's my inside. So what's the derivative is going to be? And the outside is e to the u. So the derivative of e to the u is e to the u, but instead of u, I put f of x. Derivative of the outside, evaluate at the inside, times the derivative of the inside, which is f prime of x. Okay, so the student who answered the question did not give me f prime. You cannot do that because this is not x. If it was e to the x, yes, but this is a function of x. There is an inside function. I need the chain rule. So that's again a chain rule, a product followed by, it's a product followed by a chain rule. Okay, and I can, we can really play a lot of games with those kind of problems. All right, so now I go back to the question you asked, but understanding this is crucial for us to understand how to do those implicit differentiation type problems. Okay, so now I go through the list and I'll do them basically one by one, and I will ask you to do some in front of you to have a good understanding. Right? So I'll start with number 5. And here's the question. Okay, so it's the first basic one. So we have x equal y squared, and the question is find dy dx. Okay, using the idea of implicit differentiation. Okay, so what's the idea of implicit differentiation? X is y squared. If I sketch the graph of this function, I'm gonna get something like that. That's really the idea. So here for every x, basically there are 2 y's. So y is not a function of x because if I give you an x, you can find 2 y's. But the problem is I'm still interested in finding the tangent line. It means I'm still interested to find the derivative. It means I want the change of y over the change in x. I still want to do that when the change in x becomes very small. That's really what it is. Okay, so how I'm going to do that? Okay, there are two ways. One, work in this, only this problem. It will not work with the others. And one, work all the time. So if I want to solve for y as a function of x, as I did last time, if I want to find the slope here, I want to know, okay, what is y? I need delta y, delta x. So what is y in function of x? I'm going to get y equal root x. However, if I have a point down here and I ask myself the same question, then y would be the minus root x. So if I want to find the derivative here, I have to use this formula. Because if I need to compute f of x plus h minus f of x over h, I need this formula. Down here, I need a totally different formula. So the question is, how can I avoid having to do this? And that's really the idea of implicit differentiation. So it works like this. In the back of my mind, I will say, you know, y is a function of x, but this function changes according to where I am. So I don't want to worry about the actual formula, but I want to keep in my mind that it is a function of x. So I will do this problem in two ways, a long way and a shorter way. The long way is for you to understand what I'm doing. The shorter way is we need to do it in a short way. So in the back of my mind, I say, you know, it's not a y here. It's a certain function of x, but this function is actually changing with the point. But I don't want to worry about that. What I want is f prime. I want the derivative, or dy dx. Okay, so I say if x equal x squared, so those two functions are equal, it means they have the same slope. It means the same derivative. So I differentiate both with respect to x. So that's the derivative of that. I'm not multiplying by d dx. I'm finding the derivative of that. Is the derivative of f of x squared. And my pencil died. Okay. Now, the derivative of x is 1 equal. Now, what's the derivative of f of x squared? That's what I would try to do at the beginning. This is now my inside. So it's the derivative of the outside, which is the u squared, evaluated at the inside, times the derivative of the inside. And now I want f prime. So f prime would be 1 over, I solve for f prime, 2 times f of x. So now, here's the question. If I want the derivative at the point, like if x is 1, this point here is 1, 1. If I want the derivative at 1, 1, it means 1 here, the f of x is 1, I plug in 1, I'll get a half. If I want the derivative here, I plug in -1 for the output to give me -1/2. So I don't have really to worry about that. So this is, I call it in a way, the long way. The only long way because instead of keeping y, I just wrote f of x to it. Now, the same way, but since we're smart, instead of writing f of x along all the time, I said, you know, I keep y, and then I keep in my mind that y is a function of x. So another way or another notation, if you want, is like this. I say, okay, or I say yx is y squared, but y is a function of x. But instead of writing f of x, I keep it y, but I keep in my mind that's what's going on. Then I say, okay, the derivative with respect to x of this is the derivative with respect to x of y squared. So the only thing I'm doing, instead of putting f of x, I'm keeping it as a y. So this will give me the following. The derivative of x is 1 equal. Now what's the derivative of y squared? Remember, it's not a y here. This is a function of x that sometimes I know, like in this problem, most of the time I wouldn't know. So this is y, for me now, is my inside. This is my f of x. So the derivative is going to be the derivative of the u square, which is 2, evaluated at y, times the derivative of y. You can write it dy dx, or you can write it y prime. And now I solve for y prime. Will give me y prime equal 1 over 2y. Okay, so, or if you want dy dx is 1 over 2y. Remember, dy dx is a notation for y prime. It's the change of y over the change in x. Right? Now we're going to do your other problems. And okay, so I will look at number 7. Then we're going to sketch some. If we have time, we will sketch some of them. I mean, not sketch them. We will see how they look like. So let's look at number 7. So number 7 is sine of y plus 2 equal to x. Okay. And I need to find dy dx. Now, if I sketch this function, actually, it's look like a sine, but it's going to look something like that. That's how the function is look like. There is a sine involved. So for 1x, actually, I have a lot of y's. Okay. So if I want find a slope here, I need a function that gives me y as a function of x here. And there is another one that gives me here. So there are, for every point, I have a different function that gives me the y as a function of x. But I don't want to sit down and find all of them. So the way we're going to say, okay, say, you know, y is a function of x, but it's changing. Right here is one rule, one here is another, it's changing. So the way we're going to proceed is like this. I say, okay, I keep this in mind and I proceed. I say, since those two functions are equal, their derivative is the same. That should be the first step. You're not multiplying by d dx. As you find it's the derivative of that equal to the derivative of this. And now you help me with the rest. What's the derivative of x? That's a 1. No big deal. What's the derivative of sine of y? Now back to you. Remember, it's not a y here. Unless you keep this in mind, okay, if I work hard, I can solve for y as a function of x. So this is not a y as a function of x, but it's not easy to find. So what is the derivative of sine y? No, Kian, it's not. Why it's not? Because it's not a y in here. It's not a y. What's here is actually sine of f of x. That's what you have. Unless you keep this in mind, we will not be able to do that. It's not the sine, because y is a function of x, but the rule is changing. But for us, it's not a y, it's a function of x. So if I tell you find the derivative of sine of f, you tell me it's the derivative of the outside evaluated at the inside times the derivative of the inside. And that's the same picture here. But it's a bit more abstract because I don't know what f is. So the derivative here is going to be, the cosine of y, which is f, times the derivative of the inside, that I can call it y prime. Now I solve for y prime. So first we differentiate both sides and solve for y prime, which gives me y prime equal 1 over the cosine of y. Okay, so that's that. If you're stuck in those problems, okay, in your mind say, you know, it's not a y, it's f of x. So how would I deal if I had an f of x? That's why I started with those. That's how you deal with it. And that's how you're going to be able to conquer those problems. So I'm going to do number 17. And please, I will ask you questions every time till all of you get them down. So number 17 is the following. So we have, so again, it's a sine. Okay, it's 5 x to the power 4 minus 5. And this has two questions. Part A is find dy dx, which is another word to say find. Okay, and the second question, they want to the slope of the curve at a given point. So we're gonna do part A first. So sine y equal 5x4 minus 5. So again, so we're gonna say, so sine of y equals 5x to the power 4 minus 5. And I always write here to the right that actually y is a function of x, but it's hard for me to solve for it. It is a function, but it's hard for me to solve for it. So I'm gonna say the derivative with respect to x of this equal the derivative with respect to x of this term. So the derivative with respect to x of sine y is the derivative with respect to x of this term right there. So let's use equal to. Now here, derivative of x, there is nothing really deep here. Derivative of 5x4 is 20x cubed. The derivative of 5, it's a 0. Now, derivative of sine y, remember that's the derivative of x sine y. So it's gonna give me the cosine of y, just because I just did it a minute ago, times y prime, or dy dx. Now solve. So after we differentiate, we solve for y prime. So to solve for y prime here, I divide by cosine y both sides. So that will give me dy dx or y prime. Now the question is, they want the slope of the curve. Find the slope. Slope of the curve, it means slope of the tangent line. That's what they mean. So even if they don't write tangent line, but that's what I meant. Slope of the tangent line at the point 1 pi. So it means that, okay, they want dy dx at the point 1 pi. Right. What is dy dx at the point 1 pi? It means we plug in 1 for x and pi and pi for y. So it's 20 over the cosine of pi. Now the cosine of pi is minus 1. That will give you minus 20. That's the slope of the tangent line. Okay. Now, ask you a following question. Do they have to give you the x and the y coordinate of the point?
No.
Do they have to give you the x and the y coordinate?
They just one of them, the x.
What?
Only the x, so you can plug in the x into the original function, you can get the y.
Okay, is it easy? So if they give me the x, it means the original function will give you sine y equal 5 minus 5 equal to 0, correct?
Yeah.
Now, however, that's the issue. What is y? So you're right, you're absolutely right, but let me keep working with you. If the sine of y is 0, what is the y?
Sine
out. What?
I don't know. Wherever the sign is 0 on the unit circle, that's where it would be. So pi.
I want answers. You're right. I want answers. I'm pushing you. So the sine of y is the y coordinate, basically. Okay, so one is this 0 here.
Yeah.
Which is what?
Well, 2 pi or 0. Or 0, yeah.
0. Here, what's this?
Negative pi?
No, not necessary. It's pi.
Oh, pi, yeah.
You go around.
2 pi.
You go around.
3 pi, 4 pi.
So how many value of y there is for 1x?
Infinite.
So do they need to give you the second one?
Yes.
Otherwise, you don't know which one you want.
Mhm.
You know the difference? That's really the issue here. But for 1x, for a value for 1x, there are a lot of y's. So they have to give you the other y's. Otherwise, you tell me which one you want. Because there are a lot of y's for this. Let me graph this function a little bit so you understand. So I will share the screen and I will sketch the graph. Let me see, where is it? Okay, I use Desmos for that, and I'm going to sketch the graph. So the function is sine y equal 5x4 minus 5. Okay, so this is the function. That's how to, it's a really weird function. So it's zigzagging. And you realize for 1x, you have infinitely many y's, infinitely many y's, infinitely many y's, infinitely many y's. That's really what's happening. So this is your 1. That's x equal to 1. And how many y's? Y equals 0. That's the y equal pi. That's the y equal 2 pi. And it's keep going and going and going. So that's really what. If I zoom in a little bit, it will be easier for us to see. So that's x equal 1. That's the pi. And now if I go up a little bit, that's the 2 pi. I go up a little bit, that's the 3 pi. That's really what's happening here. So for 1x, there are a lot of y's. And that's the question is, okay, what's the slope? They want it right there. They want at 1 pi, so the slope turned out to be a negative number, because if you draw the tangent line here, it's going to be descending. That's the one we're after. So let us move on. So this took care of number 17, number 21. Okay, that's not a hard one. XY equal to 7. And the first question is we need to find dy dx. And the second question, the slope. All right, so dy dx, I give you 1 minute to do that quickly, because I would like to do some harder one. So do the way I'm thinking about it. You say, you know, y is a function of x, but I don't know what it is, even though this is a simple scenario. And then, okay, you differentiate both sides with respect to x and then fill it out. All right, you guys got, are you done? What did you get? Anybody? What did you get for y prime?
Negative y over x.
Negative y over x. Do you agree with him? Okay, let's check him out. xy equal the derivative of 7. Okay, that's equal to derivative of 7, that's a constant, which is 0. What's the derivative of xy? Immediately now, product rule. Immediately. What does the product rule tells me? It's the derivative of x times y plus x times the derivative of y. All right, now derivative of x is 1. So I will get y plus x y prime equal to 0. Okay, and now I solve. Once you hit this stage, then we solve for y prime. We have to solve for y prime. So how do we solve for y prime? I need to isolate it. So I put xy prime equal minus y. Y prime is minus y over x, or dy dx is equal to that. Okay, for those who got it correct, it's good. Now, part B is that we want the slope of the curve, which means the slope of the tangent line, at a specific point, and they want it at 1,7, which is definitely on the curve. Otherwise, it's nonsense. If I put 1 for x, 7 for y, I get 7. So now I just plug in. So I need dy dx, at 1,7 equal to minus, I plug in 7 for y and 1 for x. It's minus 7. Okay. Okay. Now let's do number 47, and then I hope to do at least one more with you. So let's look at numbers for, I have no idea of introducing anything new today before the exam. That's my, well, I want you to get this under your belt. So 47 is the following. We have equation x squared plus xy plus y squared equal to 7. And that's the question. Let me read the question. Verify that the given point lie on the curve. So they give me a point, which is 2, 1. I want to verify it's on the curve, and then they want me to find the equation of the tangent line at this point. Okay, so let us verify it's on the curve. What does it mean? It means if I plug in 2 for x in here and 1 for y, this equation is satisfied. Let us see. I do that. Is it true? I get a 4 here. X is a 2, y is a 1, plus a 1. The question, is it equal to 7? Definitely so. So the point is on the curve. And then they graph the curve. It's like a like an ellipse, basically. So they gave us the graph, and it's almost like an ellipse. In 164, you will guys figure out how to write this as an ellipse. So, and the point 2, 1 is somewhere in here. And they want me to find the slope of, sorry, the equation of this line. That's really what they want me to do. And that's the point 2, 1. Okay. So as you realize, again, we have the issue. We have really an issue for one x. We have 2 different y's. So if my point here, you know, we can, and we try to solve for y as a function of x, you get one formula, and here we get a totally different formula. And the implicit differentiation works like, in a way, like in magic. If they told me you don't have to find the formula, you can still find the derivative. So we're going to find the derivative so I can find the slope of this line. Once I have to find the slope, I know the point. So basically, I want the delta y, that's what I want, dy dx, when the x is small. So what's the derivative? How do we do that? We take this expression and we say derivative with respect to x of this is the derivative with respect to x of that. So now this is x squared plus xy plus y squared equal to this. Okay, all right. This is a constant, so the derivative here, it's a 0. Now, what's the derivative? So this one I have to do it term by term. The derivative of x squared, if you want, we can split it. I'm going to be a little bit slow here. Plus the derivative of xy plus the derivative of y squared. And then I will do them one by one. So I use what you call the sum rule, if you want. Now, derivative of x squared, that's simple, 2x. Plus, what's the derivative of xy? Okay, that's product rule, crucial. It's the derivative of x. So from here to here, we're using the product rule. Derivative of x, which is a 1, times y. Be very careful. Plus x times what? Times what?
Y prime.
Times y prime, because this is a function of x. Plus, what's the derivative of y squared? All of you.
2y. 2.
When I'm silent, it means I don't like the answer. What's the derivative of y squared?
2 times y prime.
Absolutely. It's 2y prime. Y is, what is this? Is this what this y represent? This y is not a y. It depends on x. I don't know what it is. That's really my issue here. To be able to know what y is a function of x, I need to solve for y, which is not impossible, but it's not very easy. So to be able to know what f of x is, I have to go back here and find a formula for y as a function of x. It means I have to solve this for y, which is not always a simple issue. Okay, so it's not a y here. That's something that depend on x that we don't know, and we don't want to know. I don't care about it. That's really the idea. But I care about the slope right there. Okay, so now I differentiate. Now what should I do after that? What do I do after I do the differentiation correctly? What do I do?
Solve for y prime.
Right, now we have to solve for y prime. Okay, how do I solve for y prime? I need to isolate the y prime. So everything in y prime should stay in one side. Everything that has nothing to do with y prime go to the other side. Now, so I put parentheses here because when you differentiate, we have to be careful. I'm gonna remove the parentheses because they don't seem to be needed anymore. Now I want to isolate. Exactly, I want to solve for y prime. So everything in y prime together and the constant term from the other side. So 2x to become minus 2x minus y, and this would become y prime times x plus 2y. Okay, so what I did here is I need to solve for y prime. So basically I had x plus 2y y prime. Now I need to solve for y prime, so I factored it out. I get, and then this equal to this. So this will let me y prime equal minus 2x minus y over x plus 2y. So that's my dy dx. That's derivative. So now, whichever point you want, wherever you are, as long as you know the point, you know the slope by using this formula. So now slope equals your tangent line. Okay. So the first thing, I need the slope. The slope is you evaluate that at the given point, which is 2, 1. All right, at the given point, what do we get? X is 2, so I will have minus a 4, and the y is 1 over x. X is a 1, sorry, x is a 2 plus y is 1. So I multiplied this by, so it's going to give me minus 5 over 4. And now the equation. I use a point slope for y minus 1 equal minus 5 over 4 times x minus 2. Oh, yeah. So that's my slope. And that's the point right there. Okay. All right. I will look at one more problem, and then you guys practice them a little bit more and you ask more questions for tomorrow. Okay, questions? All right. So I will look at, I don't know, somehow I have 61 on my list. I don't know why I have 61. Okay, so let's look at number 61. We have the following: x plus y squared minus y equal to 1. And the question is, find equations of all lines tangent to the curve at the given value of x. So they gave me x equal to 1. And they drew the curve for us to make things easy. And the question is, I have to find the slope of the tangent line at all points of the curve when x equal to 1. So now, if x is 1, according to the picture here, how many y values I have? According to the picture, x equal to 1, I have 2 y values, one here and one here. And they want me to find the slope of the tangent line here and here. Okay, at both points. Okay, so how are we going to do that? Okay, Gavin told
That's fine. I'm on mute.
What? I'm listening. Okay, so first we have to find y prime. Exactly. And then we have to find this point and this point, basically, and figure out the both slopes. So first, y prime. So again, I said the derivative of that equal the derivative of this. So this is x plus y squared minus y. Now I differentiate very clearly. X is 1 by now. Y squared, it's 2y. So that's my chain rule now. So from here to here is the chain rule times the derivative of y minus what? All of you, I need 1 minute, 2 minutes, I will be done. Minus what? Is Gavin correct? Minus y prime. It's not minus 1 because this is not x. If you have x, the derivative is 1. This is not x. That's a certain function of x. Okay, minus y prime. Now I have to isolate, solve for y prime. We get 2y prime minus y prime is minus 1. Am I isolating it? Now I have to factor it out to be able to solve. And then I get my y prime or my dy dx. I write y prime just because it's simpler. Now I want the slope here and I want the slope here. But what's this point here? Okay, so I know the derivative. Now I need the slope here and the slope here. But to be able to find it, I need to find those 2 points. What are those 2 points? So now this is the derivative. Now we need to find the points. Okay, all right, somebody is giving me the answer, but let us do it. Suppose x equal to 1. So we know x equal to 1. And the point is on the curve. It means to find the y, I'm going to plug in 1 in here and solve for y. So to find 1, I'm going to plug 1 in here. So I will have 1 plus y squared minus y equal to 1. Okay, that's how we're going to, you don't have to guess it. You actually plug in 1 into the formula. Okay, plus 1 minus 1, so you will get y squared minus y equal to 0, because sometimes they are not easy to see. Now I factor out y minus 1 equal to 0. It means y equals 0 and y equal to 1. So the point on the curve, so if I draw the curve again, the points are, if x is 1, that's 1 point, and there is another one right here, that's 1, 1. So if you give me x equal to 1 and they tell me find, I plug in the 1 into the formula and I proceed. And now I want the slope here and the slope here. Now that's easy. So now the slope at the point 1, 0 is basically it's dy dx at the point 1, 0, which is minus 1 over. At 0, it means minus 1, which is 1. Now the slope at 1, 1. Sorry, I'm taking a little bit over. equal to -1 over my y is 1 -1. It means 2 minus 1, of course, and it's a 1, which gonna give me a -1, negative and positive. Okay. All right, sorry for taking extra time. I wanna make sure you guys get those. So for tomorrow, I'm gonna assign on my lab, if you want, like 2 or 3 problems that the same idea, so you practice them. And I hope you guys start doing the review. Your answers is on Blackboard, so come back tomorrow with questions from the review and I'll answer any questions you have. Okay? Any questions before we quit? All right, for those who have any questions, any clarifications, meet me on my Zoom hours right now. Bye for now.